Up until now, we've been starting nodes without specifying where these nodes are physically located. However, in a distributed cluster, it's important to understand where nodes are located to increase resiliency and mitigate unnecessary latency. In this lesson, we'll show you how to set up location awareness on your servers, and then how to find where your replicas live. This is where the locality flag comes in handy. When starting a node with the cockroach start command, you can use the locality flag to assign arbitrary key value pairs that describe the location of the node. This might include country, region, or availability zone. While the choice of what keys and values you use are arbitrary, key value pairs should be sensible, so if you're using a cloud provider, their region and zone names would make sense. Regardless, they need to be ordered from most inclusive to least inclusive, for example, country before region, and the keys and the order of the key value pairs must be the same on all nodes. Let's look at an example with two localities defined, country and region. CockroachDB attempts to spread replicas evenly across the cluster based on locality, with the order determining the priority. While this helps with resiliency, it doesn't address latency in a geographically distributed cluster. We'll address latency in a geo-distributed cluster in a later lesson. Let's start a 3-node cluster and use locality flags. First, I'll start node 1. Then I'll start node 2 and node 3. Note that I'm starting all 3 nodes with the locality set to the same country and region. Then I'll use the cockroach init command to initialize the cluster. By default, CockroachDB tries to balance data evenly across specified localities. At this point, since all 3 of the initial nodes have the same locality, the data is distributed evenly across the 3 of them. This means that for each range, 1 replica is on each node. Let's check the admin UI. And we can see that the replicas have been evenly distributed across the 3 US East nodes. Now I'll add 6 more nodes, this time using the locality flag to indicate that 3 nodes are in US Central and 3 nodes are in US West. First, I'll add node 4, then node 5, and node 6. Nodes 4, 5, and 6 are started in the US Central region. Now I'll start node 7, node 8, and node 9. Now there are 3 distinct regions in the cluster. The cluster will automatically ensure that for every range, 1 replica is on a node in the US East, 1 on a node in US Central, and 1 on a node in US West. To check this, let's create a table which initially maps to a single underlying range and check where the replicas of the range end up. It's important to note that in this example, we're only using 1 country, the United States, so our data is getting distributed based on the region. If we had a different country set on some of our nodes, say Germany and China, CockroachDB would have prioritized distributing our replicas to different countries instead of different regions, since countries would come first in our localities. I'll use the cockroach workload init command to load mover schema. Then I'll use the cockroach SQL command to verify that the data was added. Great. Now that we know that the user's table has been generated correctly, I'll use the show ranges SQL statement to find what nodes the table's ranges are on. The show ranges statement returns information about the range, the nodes the replicas are on, and the replica localities. In this example, we can see that there's 1 replica in US East, 1 in US Central, and 1 in US West. We've covered how to start nodes with the locality flag and how to use the show ranges statement to view where replicas are located. You now know how to set up different localities for your cluster's nodes and how to view what nodes your ranges and replicas are on. Keep this in mind as you plan out your distributed cluster.